So welcome to this track, this session 28B, the tracks 9 and 10, workforce development and industry training, and SCILE, self and co-regulated learning in immersive learning environments. So we have two presentations, one from Russia and another from USA. So the first presentation is presented by Dmitriy Vinitskiy with the title Role of Adaptation Phase in Educational Results of Virtual Reality Communication Training for Managers. So, well, you can start, Dmitry. I go to put in the chat a document for the people to put their questions or comments. So, Dimitris, you can start. Thank you.
Thank you. Okay. So, yeah, our study started from a question of how to make virtual reality education better. Then we went to a question why so many in the literature, what we found that results of the virtual reality education were kind of inconclusive. And one meta-analysis said, it's not a direct quote, something along the lines that education in virtual reality is at least as good or not worse than other type of education, which is kind of disheartening to me personally, because it seems that virtual reality has a lot of potential, at least in some spheres, to really augment the training and educational power of your training program. So we started to look, why is that so? What the reasons for many studies to find a small effects or no effects at all. And then we looked for what's good in virtual reality, what is what could be bad in virtual reality. And I don't think it's the only thing that is actually good in virtual reality. I think there is a lot of other good and positive effects, but one positive effect that is mentioned most often is that virtual reality is interesting and has a motivational effect, so that students want to engage in virtual reality, they like it. But on the other hand, the other effect is that virtual reality brings a lot of distractions, and it risks that maybe your students, they don't really want to learn, but they would like to participate in virtual reality because it's fun. And the tricky part is that what you want to do is to maximize the positive effect and minimize the negative one, but because things that make virtual reality interesting and that stand behind the motivational effect are the same things that make that create a lot of distraction potential. So you can't do this in a straightforward way. They the same, the different sides of the one same medal. So we went on to look into how we can improve virtual reality training, but without losing on the motivational effect. And we adopted the cognitive load theory framework of Swellers and model of multimedia learning by Richard Meyer. And in cognitive load theory, it is suggested that cognitive load could be divided into intrinsic and external, where intrinsic cognitive load is something that is related to the complexity of learning material. So you probably can change much in learning material, and the external cognitive load is all the excessive possible distractive factors that you want to cut from your training program to make it better. And obviously, risks of distractions, they fall into category of the external cognitive load. And then we propose that within the VR training, we can further divide external cognitive load into everything and things that are specific to the virtual reality training. So it's factors and things that would come up in virtual reality, but and they will probably come up in virtual reality, but not in other medias. And within those, we found one that is kind of almost neglected. I think few studies we found mention it, and they say that they control for it, but it's rarely studied as a specific factor, and it is the cognitive load that is related to the lack of experience with virtual reality from the students. So basically, we couldn't find a lot of studies that targeted the factor of experience with virtual reality and its effect on the learning, which was kind of surprising because kind of on the surface. So we went on look into it, and we had three hypotheses. Hypothesis one is that adding small adaptation stage before virtual reality training would improve the educational results. Hypothesis two, we want to look into the types of adaptations stages you could use, and want to see if you can use like whatever every possible like virtual reality game, or maybe you should use something that closely resembles the training simulation you would use later. And the third hypothesis was about the cognitive load itself, and we used EEG, electroencephalogram measurements to assess whether differences in educational results would be related to the cognitive load. So in our study, we had just about 100 participants, mostly managers, and we have three experimental groups. One group had generic adaptation, where they played Oculus First Step, and for us, it was just kind of a virtual reality game that doesn't look like our training simulation. The second group had what we call specialized adaptation, and it is a simulation that was very similar to what we used in our actual training, and it was a salesman at the grocery store simulation. And third group had no adaptation stage, it was a control group. And now, a few words about the educational part of our study. So we had training for middle managers, and skill they were training in is giving the corrective feedback, which is a type of feedback you want to give to your employee when some changes in their behaviors are desired. And we used like a step-by-step learning, where we divided the complex skill into few small parts with immediate feedback, and then we combine it back together into the complex skill with the feedback after. And education itself, virtual reality training we had was in the simulation. You see the screenshot right now. It had avatar that was controlled by the artificial agent. It was heavily scripted, and it was able to, using speech recognition, to have a bit of a conversation with the participants. So they used, they spoke some replicas, and the artificial agent responded to them accordingly. And the other type of parts of user interface, they provided hints of how participants should go through this talk. So the backstory is that this is Catherine. She's your employee, your manager, and you have to give her corrective feedback on her behavior during the last meeting, which she behaved like poorly. So this is the overall look at our study. We can go back to the simulation during the question if you're interested in details. So this is how our participants path looked. Before the others phases, they had an entry-level test that was scripted like a phone conversation with an actor, and actor again played a role of an employee, and participants were the managers who had to like work out some issues with them and schedule a meeting to talk about some like problems with the current projects. Then we had adaptation phases before virtual reality training for groups 1 and 2. Control group skipped it and went straight for training itself. So first there was a bit of a theory reading, then there was the simulation we had last slide, and after the VR training and a second dialogue test. It was similar to the entry one, but with a different backstory. And blind expert who did not know which groups this participant was from, assessed it to see like the actual gain and the actual educational results between like the before and after the training. And we had EEG measurements during, we actually measured EEG during the whole experiment, but we particularly look at the cognitive load during the virtual reality training itself. And we assessed EEG using Muse headbands. Like pretty conveniently, they are compatible with the head-mounted display. As you can see, a participant who is like a first time inside VR doesn't hold the joysticks correctly. And we used the frontal leads and measured the mean theta rhyme as the measure of cognitive load. More theta rhyme there is, higher the cognitive load is. So as a result, we found that first of all, groups with adaptation did outperform the group with no adaptation. So adding adaptation stage probably helped them to learn better, which is great. It's what we predicted. Then we also found that cognitive load was lower for groups, again, with adaptation. So the graph is kind of may seem complicated, or but we used these Z scores for cognitive load measurements, and like the overall cognitive load during training was lower like than average, because like cognitive load during the dialogue test on the phone was higher. But you see that there's a like lower scores for groups with adaptation. And you can see it kind of mirrors the graph with the test results. So higher the test results, lower the cognitive load during training, which is convenient. And then we found no real differences in between the adaptation types. So as far as we can tell, it doesn't matter whether your adaptation phase looks similar to the training simulation later. And to wrap it all up, the results. As I said, adaptation phase did help and did improve the educational results. Then different adaptation types seem to have little effect on the education, and cognitive load was related to the differences. And with that, I want to say that with our study, probably we hope to stress the importance of the factor of like the previous experience of your students with the virtual reality. And like specifically for if you look at the industrial learning, you may find a lot of people that are slightly older and probably have like no experience with virtual reality or like little experience with virtual reality. So you probably want to control for it. And I hope that in virtual reality studies, some sort of control for participants' experience in VR would be made to overall improve the study field itself. Thanks for your attention, and we can go to questions. I can go over different parts of our complicated study if you want. Maybe something about the simulation or the EG measurement or the hypothesis.
Okay, thank you, Dmitry. So Sharon, you have some questions, right?
Yes, thank you. Thank you. It's interesting. I'm just curious about the bar chart that you show. What's the dialogue test? What's the y-axis? Is it results?
Yeah,
is
yeah,
it more dialogues?
No, basically the dialogues were assessed by the expert, and there was like a scoring board that participants could get, like how. So the conversations themselves should be like some structuralized, and there are like limitations of which type of language you can use and so on and so forth. So there were a lot of like a checkboard of what participant did right or wrong, and it all summed up to 18 points total. Okay. And this is the average difference in those points. So like
so that's the quality of the dialogue.
Yeah, correct. That's and this is the difference of like the entry level test and the exit level test. So before and after training, we subtracted scores like scores before training from the scores after training, and that's the difference in the score points.
Okay, and there is no differences between these groups?
Statistically, no.
How many experts?
We unfortunately had only one expert from this one, but she had a pretty strict scoreline, and she was blind to the group's participants for it.
Mm-hmm.
Okay, thank you. You have more questions, Sharon? No?
I could keep asking, but just let someone else have a chance.
Okay. More else? Anybody you want to make some questions for Dmitry? Dmitry, I have one question about the feedback. The participants have instructions to give the feedback. So what is the dimensions that that is analyzed in terms of feedback? Is only correct or wrong and give points, or they are instructions to give and
okay. So we had during our training we had a pretty specific program they were learned, and it was taken from a corporate standard of a big processing company that kind of had this like a rule set of recommendations for their managers, and it had like step by step, like a roadmap of how you should structure the talk with the employee, what you should say during all the phases. Like you should start conversation with like making a contact with them, like asking them something, and then you shouldn't be direct and move to the issue itself, and so on and so forth. So pretty basic things, but yeah, they sound simple, but actually not that easy for managers or participants to follow correctly from the get-go. So basically, they were scored on how different they were from the standards that were written.
Okay. Well, in terms of skills, you see difference between the participants that have training and the people that don't have training in terms of the regulation of their learning?
They all went through the training phase, but experimental groups before training have adaptation, and the adaptation stage itself had no it was not related to the training they got after it. So basically at this point, they just learned how to like use the VR and nothing else. And at this stage, second stage, they actually learned the programs. So basically the idea is that when someone who has no VR experience has to learn something in VR, he has to learn both things at the same time, has to learn VR and the material, and you can do both well, probably. So we tried to separate those phases.
Okay, thank you, Dmitry. So if no more questions, we move to the next presentation. Okay.
Thank you.
The next presentation is presented by Kimi Sun from Santa Clara University from United States, with the title Immersive Educational Recycling Assistant Era, Learning Waste Sorting in Augmented Reality. You can start, Kimi.
Thank you. Let me share my screen. Okay. Hello, everyone. So my topic today is an educational recycling assistant to learn waste sorting in augmented reality. And I am Qiming Sun from Santa Clara University. I'm a first-year PhD student here, and my advisor is Dr. Xiao. So okay, so in my presentation, I will go through our research background and research questions. I will show some existing solutions currently and move to our proposed solution in an educational technology approach. And then I will discuss our studies and findings, as well as some limitations and our future works. Okay. So here's our background. So we observed that there are some problems in waste management scenarios in our daily life, that our everyday trash are often very messy, and which consists of recyclable and non-recyclable materials combined together, and also the waste classification might be very confusing. So if we look at this figure here, and here's a trash can in our campus in California, and we can see that some similar items made of different materials could fall into different categories, and the signs here are not not interactive at all, and they are also not informative enough. So it makes many confusion when we sort the waste. And then, so here we established our problem statement, which there is limited educational technology support to provide correct learning feedback in addressing the daily need, and there's a global concern in waste classification. So here we have our 3 research questions. The first one is, what are the impacts of augmented reality on garbage disposal experience and process? And how does waste management pre-knowledge could affect the garbage disposal behavior? And also, what are the learning outcomes after using our proposed app, the Educational Recycling Assistant? So before we build our app, there are some existing solutions that have a waste management process. So such as the iBeacon app. So this mobile app gives suggestions while we're buying from a vending machine, and there is a mobile app that can connect their modified trash bins through Bluetooth and give suggestions on which bin to dispose the garbage. And also Waste Wizard also address auto sorting trash bins to by using some machine learning technologies to automatically sort the trash. Also, there's also a proposed bins with interactive and playful interface built on it to let you track your history and play with its entire sorting process. Also, there's an app called Pair, which is a virtual pet in augmented reality that directs users to collect garbage from the real world. So these are some existing solutions to address some concerns. So here is our proposed solution. So our app contains a waste scanner with a real-time object detector to classify the waste using the camera, and also we deployed the AI functions into the app, and as we can see in the third figure here, when users are using the app near the trash bins, the correct bins will be labeled as there's a tick on the bins, and in this virtual environment. So this is our design of this EdTech app. So in our architecture, we use AR code to first track the predefined labels in the frames captured by the camera. We also integrated our built-in detector. So to create this detector, we first created a waste data set from several open data sets, such as TrashNet, open image data sets, and Taco data set, and as well as plus our own images. So we first constitute a data set with about 5,000 images in total. And then we apply some image augmentation techniques, such as blur, crop, and some modifications and colors. So, and then we finally we get a data set contains over 8,000 images within it. Then we trained the real-time waste detection model using the efficient DET architecture for for the detection purposes, and the model could detect waves with average precision of about 0.79, and under the intersection of units is 0.5%, which is 50% of intersection of units. So this is our overall architecture here. We use a scene form to render the air scene from the detectors and present that scene to the user. Then after we developed this app, we conducted a user study to test if the app is effective. We recruited 28 students from a web usability class, and we constructed two hypotheses here. The first one is the participants' pre-knowledge on the items correlates to the recycling accuracy, and the apps could positively help increase the users' accuracy of recycling, especially in the complex garbage items. So we assigned two tasks to each student. There are two types of tasks. So the first type is to identify the single items there are two single items in this task, which is something like the crumbed paper, napkins, a coffee cup, and also the task that contains two sets of items such as straw and plastic cup, the plastic bag with the receipt. So this second tab is the garbages here are more complex with the first task. So we are comparing the results of them to identify how the effect would be by using our app. So the chart below here shows the entire process of our study. So we first let user take a pre-knowledge survey to see how their knowledge is, what are their pre-knowledges in West sorting, and then we divide users into two groups. So the first group, the users are directed to throw away garbage without our app at first, and then we introduce our app to them to let them throw away the garbage with the help of our app. And the second group, we let them throw the garbage with our app at first, and then we let them throw the garbage without our app to see if they have any improvements by using our app. And for these two types of groups, we ask them to complete a post-knowledge survey, and we also ask them to give us some feedback on the interface design and some interview about the usage of our app. So this is our basically our entire study of our app, and the results is pretty good actually. Firstly, the users with the support of app achieved a significantly higher classification accuracy than the users without the support of app, and especially on the items with multiple garbages with different categories, such as like we say. So for a single item, the users could approach 100% accuracy after by using our error app, and for multiple items, the accuracy increased from 42% to 92%, which is a very significant increase in terms of accuracy. And for the pre-knowledge, which is for the post-knowledge, which is how the user's knowledge, how users gain more knowledge by using the app. And the result shows that students could gain a significantly higher post-knowledge after the study. And as we can see here, so for the simple items such as paper and napkins, users could identify them correctly at first, and after the use of our app, they could gain, it could achieve even higher accuracy on identifying these two types of single items. On the complex items, such as straw and cup, the coffee cup, the plastic bag and the receipt, so they could identify these items which are with an even higher accuracy. So these items originally could be considered hard to categorize, and after using the app, they could categorize them in a better manner. So in our survey and interviews, we distributed them with surveys. We use some 5-point Likert questions on the usability, and the result shows that the users praised and recommended the app, and they feel confident while using the app. So in terms of the interview feedbacks, users give us some general challenges in terms of the West setting in a journal scenario. So first, they feel confused on categorizing the items, and there is uncertainty in separating the recycling and the compost items. So these are the general challenges that they feel in their daily sorting. And the general concerns are the uneasiness after discussing the items, and especially a set of complex items such as food, cabs, dirty items, and electronics. So its challenges and concerns are something they most fear about in a scenario of disposing of garbage. Well, there are also some limitations in our app. So the first thing is about the accuracy of our detectors. The current data set, well, we consider it is large, but for the things the scenario of garbage classification is very huge. So the training size is still small compared to if we put it into this very large scenarios, and currently it only limited to identify the finite common categories. And there are also some bottlenecks for performing the real-time object detection on a cell phone. And also in design aspects, some students using our app suggested to give more animations and give some learning functions to improve the user experience during the sorting process. So since this app was developed by like last year, so after this we made some progress. Basically, we improved the homepage with some like daily tips, and we improved the object detectors to allow the modifications of labels, and we also develop some functions to let them track the carbon footprints, to log them in a calendar and we used some algorithm to calculate how much carbon they saved to give them more intuitive estimations of how many contributions they made to the environment. And these are some of our work in progress. Okay, so basically, in summary, we created an educational technology to aid with the classification and enhance the recycling awareness. And we conducted a usability study to assess the app's effectiveness, and the results. And as a result, users feel quite confident while using the app, and their waste management knowledge will improve. So the experiment. And yeah, thank you for listening, and I'll be happy to answer any questions.
Thank you, Sun, for your presentation. It's very interesting, your application, your hub. So, any presents have some questions for Sun? Well, we have in the chat, Nekan, you can turn your micro, or you prefer that I read your questions?
Sorry?
You have two questions in the chat. The first,
oh,
okay,
I'm sorry, I didn't.
Yes, I read for you. The first question is, who are the students and what are their demographics? The second question is, what informed the need for this app?
Yes, thank you for reading it for me. Yeah. So the students are hired from our a class in our college, from a usability class. They are basically the junior or senior students in our university. So I would say the demographics are quite not that diverse, since they are students they are all with a very similar backgrounds, because they are from the same class. And yeah, that's actually what we could improve further to introduce more population to test the app. And secondly, what informed the need for this app? Well, yes, the need for this app, I would say it is used to solve the problems of waste classification, and we want to users, by using the app, they don't need to think about which categories they put the garbage in. Like in California, it's quite complex to like a straws could, like if you are drinking a cup of bubble tea, the straws should be in landfill and the cup should be put in recycle. So it's quite complex. And by using an app, it automatically detects the categories of different components of garbage. And you can just put, it also highlights the correct trash bins to put in. So by using this app, you could achieve this.
And ultimately just provide this as a function, as a tool to help people learn, because we believe in this field, you have to continuously learn about how to manage personal waste.
Yes.
Thank you. More questions for Sun? Sun, I have one question for you. In terms of the behavior of the participants, you see some difference when they use the hubs, for example, when give some information, they're changing their behavior, or not see that in terms of this, the organization of the information, the put the objects, what is the difference? that you in your observations?
Okay, so well, the difference would be, well, let me. Did you mean?
I could answer that. So because of the study, it's only a few minutes. So it's really hard to actually reflect the user's real behavior. But this is a good question. Actually, this summer, we plan on to have all this technology being used back at home. So we will be able to collect a more close to reality when they will be using what. So it's not so much manipulated on, the task on the items. Right, so then we will be able to really look at their behavior. But we do have other studies that's really trying to see how they will use this app, the sequence of how they are using it. And if you're interested in that, stay tuned, check on our website.
Yes, of course. In terms of the self-regulation, these apps can be help the participants to learn of about this. So I'm curious about the effects of this app in terms of this regulation of learning of in participants. I know it's very difficult with this duration of the experiment, but well, I'm waiting for your future work. Thank you so much. Well, so we finish this session. I put in the chat again the link for you put again the questions for the other authors. I remind you the link for the choose the best presentation. Okay, and I think I think it's running as another sessions. You can go to them, or we can continue in this session and discuss something. And well, it's a pleasure to be here with you. So thank you so much, and enjoy the rest of the conference.